Jump right back into humidifiers. You remember our conversation last week? We were talking about humidifier maintenance and kind of how they work and what the purpose is of humidifiers on our systems. And we talked about the simple systems, the Aprilators, the flow through type, and how they have a very simple control system on them. Anybody remember what the controls are on those? On the Aprilators?
No.
Current sensing relay, and then a humidistat. And very oftentimes, the ones that you guys are maintaining, you're going to see that humidistat in the return ductwork. And we're going to set that 35, 45%. With those Aprilator flow throughs, you really don't run the danger of over humidifying or causing too much damage inside the system. So it's okay to just turn those things at 45, make sure they go on and off with the fan. They shouldn't run if there's no fan running, okay? But that's the simple system. The steam systems are much more sophisticated because raw steam, we ended the meeting by talking about how raw steam can cause some serious damage. So there's a steam hose that's connected to the steam cylinder inside the humidifier, and it's also connected to a nozzle on the ductwork. It uses hose clamps. On the steam cylinder itself and on the steam nozzle, it's often a plastic composite the bottle is, it's a plastic composite connection. And we're dealing with steam, right? High temperature, low pressure steam. So that plastic is always expanding and contracting. That rubber hose is always expanding and contracting. So that hose clamp can loosen up, especially after a full season of operation. So it's important to check those hose clamps when we're doing maintenance. Okay, and I ended last week by talking about the house that I walked into where it had popped off the nozzle, so the steam hose was pointing straight up at the floor, at the ceiling in the basement, which is a wood floor up above, and that hardwood floor had completely destroyed the hardwood floor. It had a 3-foot lift in it in the middle of the floor where the steam was just dumping underneath.
I forgot to mention the nozzles sticking up, so the water.
Nozzles also want to be at an angle so that they can drain, right? There's two types of steam nozzles out there. There's one that's like, oh, that's not a good marker. There's an old one that's like, it's mounted on the ductwork, and inside it just kind of looks like this, right? And the steam does this. This has to be pitched on an angle because the way that the steam hose attaches to it like this, and then on the bottom there's another small piece that's a drain. Because you're going to end up with condensation inside that nozzle. And that condensation's got to drain out. So pitch is important. Ductwork is usually plumb on the side. So sometimes when we put the screw in there, we might put a couple of washers just to make sure that's pitched. The newer style ones that are being installed are an actual tube. There's an actual steam tube, a distribution tube, and it has a bunch of holes on the top like AJ was just noting. And the steam drifts out. And that also has some kind of draining element in there. So the pitch on that, so you always want to be pitching back. You always want to be pitching all the way back to the steam cylinder because there's condensation that's happening in the hose too, so that has to be pitched.
And you have water in your ductwork, then you'll be able to put the heck in it.
And it makes a mess, and it's,
You don't know where it's going.
you know, water is just a big pain because it causes damage and it creates service calls. So the controls on our steam humidifiers is critical because we want safeties in place to make sure that that's not making too much steam or making steam when it's not supposed to be making steam. So the most important component that we have is our humidistat. And we can call that like a low limit humidistat. And I'm going to draw a very basic design and installation for you guys, okay? So you have somewhat of a visual. And here's some ductwork. This is some return ductwork, okay? It's pretty beautiful. I'll agree with that. This is an air handler. So let's say we mount a steam humidifier. Let's say we just mounted it on the side of the air handler here, and that's got a drain that's going to go into a condensate pump. You'll see that, and then it has that steam hose that comes off, and here's our nozzle, and then the drain line that usually just goes back into the steam humidifier. And then we have a bunch of low voltage controls. It's going to vary on almost every job. You'll see some jobs that are all installed the same way, and then you'll see little variances in all the different jobs as far as where we put these controls and what the operating limits are and so on and so forth. But the components that you're going to see most often is an operating humidistat, right? A low limit. There's a bunch of different things to call it. It's a humidistat. And basically we'll just call it humidistat.
Yeah, low, I see what you're saying, a low limit and high limit.
The reason I call it a low limit or an operating limit is because it limits the operation, number one, right? It reaches a certain sensing level and it turns the humidifier off. We put them in the return ductwork. Why do you think we would mount it in the return ductwork?
Good air coming back from upstairs.
So it senses the return air that's coming back from the space, and it's reading the RH, the relative humidity in that return air. So that's telling this humidistat that it's currently 25% humidity in the space. We're setting this for, let's call it 35% as our setting. So if the air coming back is at 20%, we're going to make this switch is going to say, I need humidification. Okay? But that's not enough. We need more information to know if it's okay to operate the steam humidifier. We want to collect more data. So another control that we install is an airflow switch. Okay? And that's going to sense from our supply and sometimes from our return. Sometimes just from one. Okay? And that's a diaphragm pressure switch, a differential pressure switch. Well, it would be a differential if we were sensing from both. But it's a pressure switch. And when the fan comes on and it blows into one side of that, there's a diaphragm inside that switch which closes a set of contacts. We all, at this point, pretty much understand what I mean when I say open contacts and closed contacts. We all pretty much understand that. Okay, we'll dig into that concept a little bit more. So we have fan proving or airflow switch, right? And we're using an airflow or fan proving or pressure switch as opposed to a current sensing relay. A current sensing relay can do the same thing for us, but it's a less reliable switch. It's a less reliable electronic thing. So an air proving or fan proving switch it's more reliable. It's typically adjustable, so you can set it to what your fan speed is. You can have it match your fan speed. And sometimes a current sensing relay, especially with ECM motors, the fan will ramp all the way down. Sometimes, because you don't get that hard shutoff on the fan, that electronic relay inside that current sensing relay will stay pulled in. So there's potential there for it to leave that humidifier running. On an Aprilaire, there's not really any harm in keeping that thing running other than the noise it might be making or you're wasting some water. But on a steam unit, if we were to be pumping raw steam into that ductwork without a fan actually working, we're making a mess. We're damaging ductwork if it's internally insulated, right? And moist, dark is a recipe for mold. Okay? You also are going to make it rain in there, which could leak water down inside your air handler and damage some components. And you're also going to have some vents that are going up into the house. You're going to get some raw steam pumping out of those vents, possibly. And in some of the houses we work in, we've got wood floors with very expensive wood grills that can be damaged. Okay? So we want to use what we think is the best way to actually prove that we have airflow, that the fan is working. So we have an airflow switch, and we have a humidistat. Okay? Over the years of installing and operating these systems, we've also learned that we need even more than that.
You need a high limit.
So we put a high limit humidistat in the supply ductwork, and we put it downstream of our steam humidifier. Okay?
Make sure it makes air.
High limit. And a typical setting on a high limit, 80, 70, somewhere, right? We'll call it 80. 50 I wouldn't do, because if we've got 20% coming back and we're dumping steam in at this point, even though it's atomizing in the airstream, you could get a reading of 50%, right? Because you're saturating that air with moisture so that it can get into the house and mix with the air that's already in the house. So 50 is a little bit too low, so we'll call the high limit 80%. And what the high limit does for us is it tells us if we've got too much moisture in the duct, something can't be right. Okay?
There you go.
So we're reaching 80% saturation in that ductwork, like something's wrong. We got a problem. We've got no airflow, we've got not enough airflow, like something happened. Or those old school nozzles, the first one that I showed you, the reason we don't use those and the reason the manufacturers went away from those type of nozzles is sometimes the ends of those would pop off because of all that expanding and contracting of that hot steam and the cooling down happening in there. It was a two-piece nozzle, so the end would fall off. So the front of that had like a small screen on it. I wish I had one for an example. It had a small screen on it, which would kind of create some back pressure and limit how much steam is coming out of that nozzle. Almost like a
regulator?
Almost like a regulator or a metering device for our refrigerant, like something like that. It would create some back pressure, right? When that pops off, now you've just got all the steam pressure, tons of it blasting out in the ductwork. And in some cases, if you're running a very low fan speed, let's say the fan is on this air handler, just in the on mode, we're getting 50% fan speed if it's an ECM motor, right? We're not getting high CFM out of that. So at a very low fan speed with too much steam, you could also be saturating that ductwork. So a high limit is a safety, okay? Every one of these is a safety, even the operating limit, because that's a low limit, right? If we didn't have that, then whenever the fan comes on, we would just have steam going and we'd have no low limit. We'd have nothing limiting how much steam we're putting into the system on the low side. So the house would just keep humidifying every time the fan came on, right? So that's why we have humidistat, operating limit, low limit, high limit, fan proving, okay? Now with ECM motors coming out on the market and all these installs that we were doing, right? We started installing these things many years ago before variable speed, before ECM motors were invented and were the norm in our industry. Now they're the norm. Years ago it was, what were they called, Ryan? PSC motors?
Permanent split capacitor.
Permanent split capacitor motors? Single speed, right? On, off, on, off. There was no ramp up to a speed. There was no ramp down. On, it was off. That's when airflow switches work the best. Boom, 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 boom. Okay? A soft start. Ramp up, ramp down. Sometimes even in that ramp down, remember what we just talked about with those current sensing relays? Sometimes even in ramp down, an airflow switch might not open. It might stay closed. It happens. It's rare, but it happens. And when that happens, now the fan has shut down, but 20% air, our operating limit's still calling, okay? This is stuck closed, I should say, not on. It's stuck closed, so now we're still dumping raw steam into the ductwork. With no airflow, you have actual steam. With airflow, what happens to that steam when it leaves the steam distributor or the steam nozzle is that moisture is instantly atomized, okay? So it's not wet anymore. It's atomized in the airstream. If you don't have airflow, you have wet steam. Wet steam is, again, now damaging our ductwork, causing all kinds of potential problems with our system. So here at Alliance, when ECM motors became the norm, we decided to do another layer of safety. And we started installing a rib relay. And I'll just draw it in here. A rib relay that is energized on the coil side, 24 volts, from the fan circuit. Okay, and then we use the normally open contacts to wire it in series with all the rest of the controls. So that if there's not an intentional call for fan, a 24 volt signal for the fan to run on this system, we've got the control circuit open. And I don't know about you guys, but rib relays is one of the most reliable components we've ever installed in our industry. Okay? One of the most reliable, consistently reliable accessories that we purchased and have installed in this industry. And that's over, they weren't out 29 years ago when I started, but once they came out, and I don't think, Short term or long term, I think anybody would agree with that, right? I see Ryan's already shaking his head, like
Yeah, 'cause we used to use the old Honeywell ones, but they were loud.
they banging on, banging off.
People would freaking complain
And I
about
like
the
the
clicks.
little light, you don't have to check 24.
Well, that's what I mean. They just have so many
They're
positive.
quiet, they wire right to a box, so the connections are inside the box.
There's so many positives to a rib relay, and they just don't fail, right? And if they do, you know what went wrong. You know that there was a short or there was a high voltage situation, right, that killed it. So we put rib relays in, and we said to ourselves, okay, so 1, 2, 3, 4 controls wired in series, which means all 4 of those have to prove to be true. Okay? All 4 of them. Which means we have to have 24 volt call for fan. We have to have a call for humidity on our operating or our low limit or our humidistat, call it what you like. We have to have actual fan moving. Is it possible to have 24 volts going to the fan and no airflow?
Yeah, your blow motor's no good.
Bingo, right? It's possible. So it's possible to create a 24 volt call, which is why the airflow switch is still necessary. Okay? Which is why you still have to, not only do you want to turn the fan on, but you want to prove that it came on. Okay? And with a current sensing relay, humor me here, is it possible to send 24 volts to that fan motor, and is it possible for a current sensing relay to sense current?
Yeah, I mean,
They're finicky sometimes.
It's dicey, but they're finicky, right? It's an electronic thing, and they're finicky. If you actually have something in the ductwork telling you that, yes, I feel air, I'm sensing air, better than an electronic switch sensing an electric amp draw through a wire, right? And then we also have to go through our high limit and say, okay, that's also true. Now, the high limit being set at 80 is telling us that in this area we have less than 80% humidity, and that's what makes that true, right? That's what makes that switch close, stays closed. This one is telling us that, yes, I'm sensing airflow in the ductwork. I have a tube that's in this ductwork, and I'm sensing that I have fan speed. This is telling us that I do have a 24 volt signal for fan control, and that I am sensing that it's less than 35% humidity in the ductwork. Okay? If we have a system that has multiple trunk lines, do we ever do a system that has multiple supply trunk lines?
Yeah.
Zone dampers, right? We do that all the time. We do a lot of zone systems. In those cases, depending on where those branches are, right? Like let's say this is doing this. Okay? And then we got a zone damper.
you're running too high limits, right? Or no?
Often we're going to run too high limits because if we're doing multiple trunk lines, we may not have all the space that we need to install that steam distributor, because we want to install it in such a way that any zone will get the humidity. You don't want to put it downstream in only one of the zones. We do want all the zones to get it if possible, but it's not going to kill you if you only put it in one of the trunk lines. Why? Do you remember what we talked about, the difference between humidity and temperature last week? It's going to distribute more evenly, right? It's always going from high to low. Okay, water, humidity in the air is nothing more than water. It's just vapor, right? But it's water. Water is always seeking its own level. Do you know what I mean by that? So when you're talking about it in the form of vapor pressure, it's going from high to low, right? If it's 50% moisture or vapor pressure coming out of the supply ductwork and it's 20% in the space, that 50% is just coming out and it's getting everywhere it needs to be, okay? Temperature, we know, can vary within feet. It's right now a different temperature where I'm standing than where Jerry's sitting, right? It's 2 different temperatures. Because I'm heating up, I'm wearing a vest, I'm on the spot, and I typically run warm. I don't know about Jerry, but I can tell you that if we use thermometers, right, we were going to get different readings all around this room, and we're going to get a different reading at the floor than we do at the ceiling. But water is different. If I take this cup and I start pouring water in, and I pour the water from up here, right? What happens to the water when it gets to the top of the cup? It's just going to overflow, right? Now gravity is going to make the overflow go down, not up. But if I kept pouring from here and I filled the cup and then I filled the room, where's the water going to get? Eventually it's going to get up to the source. And then when it gets to the source, it's going to stop, right? It's always seeking its own level. So if you're pouring from this level, the water's not going to get above that. Unless you have pressure and you have a vessel, different conversation. But water is always seeking its own level no matter what form it's in. Whether it's in the form of liquid, whether it's in the form of gas as a vapor. So that's our basic installation. Do you want to start looking at the wiring of it? It's 7:27. Joellen's not here. She should be here any minute. Do we all understand the concept of wiring in series?
Yeah.
Okay? Because obviously low voltage wiring in electrical circuits is 100 lessons for another time. Okay? And if with a different color marker, 2 different color markers, we can kind of start to draw that. So we've got, think of it this way. In order to run that steam humidifier, there's one set of contacts in there that's open. And if we close those contacts, that steam humidifier is going to run. If I don't put any of those controls together and I just went into that steam humidifier and stripped down two ends of a small piece of wire and plugged them into those connections, that steam humidifier is going to run.
You also starting to see a lot of the modulating controls too, because all those steam humidifiers have the capability
Of modulating. Yeah.
And you're seeing a lot more of that these days. People purchase the fancier controls.
Oh, without a doubt. And we're going to talk more specifically about those components over time. But you're right. A lot of them are more modulating, more sophisticated. And another thing we're seeing is that the operating limit is not in the return duct, that it's up in the space now.
Yeah.
Right? Because now people have the ability and the desire to have control of that humidity. 20 years ago, people were just satisfied knowing they had a humidifier. You could tell them the humidistat's on the return ductwork. And really, if you need to boost the humidity in the space, just turn the fan on. People want more control, right? Especially with the new controls that are connected. Everybody's online, has their apps on their phones. I mean, they're controlling everything from their phones. So the more control we can give people, the better. And it is better for them to have control of that humidity because we can help them more over the phone. If they have concerns, they can tell us more information if they have control of it. But our thermostats have come a long way in the last 20 years, so those people have that. Now, if we put the humidistat up in the house, in the thermostat, right, and we give them control of it up in the house, do we still need this limit in the return ductwork?
No, not that one.
In theory, you don't. But if it's there, does it hurt anything? Because it's a low limit. You can just use it as another safety to tell you if they cranked it up to 60 or 70%, there's some thermostats that will give them the ability to do that. Right? What's the Honeywell give us for a high limit? Is it 60?